Okay, so part two, we're talking about the relationship between the position function, velocity, and acceleration. So displacement versus total distance traveled. Displacement is your net change in position. It's not the total distance traveled. Speed versus velocity. Speed is the absolute value of velocity. Velocity is a vector, it's directional. So positive sign usually means it's going up or to the right. It could be east or west, north or south, um, or it also can be, um, anyway, positive is one direction, negative is the opposite direction. And your average velocity over a given time interval is just the change in position over the change in time. So these are some practice problems similar to the homework. We're going to find the displacement and the average velocity. Then we're going to find the speed and the acceleration at the endpoints. And then we have to decide if the object changes direction. Let's start with this one. Okay, so for part A, we want to find the displacement. That's going to be the position at the end time minus the position at the beginning, which if we plug that in, we find that it is equal to 2.25 meters, which is 9/4 meters. I let Desmos do that for me because I just didn't feel like plugging it in. Now, for the average velocity, we're looking at the change in position over the change in time. So this is 9/4 divided by 3, which is 9/12, which is 3/4 meters per second. That's my average velocity. This is my displacement. Now we're going to work on part B. Find um, the speed and acceleration at the endpoints. So we need the velocity function. And remember, velocity is going to be the derivative of our position function. So this will be t cubed minus 3t squared plus 2t. At time equals 0, the velocity is 0 meters per second, and that is also the speed because it is positive, right? And when the time is equal to 3 seconds, 3 cubed is 27, minus 3 times 9, which is 27, plus 2 times t, which is 6. So this is 6 meters per second, which is also positive. So that's the speed at the endpoints. Now acceleration, see how much we can squeeze in here, will be the derivative of the velocity function. So what is that going to look like? 3t squared minus 6t plus 2. So at time t equals 0, we have acceleration is 2 meters per second squared. And at 3 seconds, we have, plug in 3. 3 times 9 is 27. 3 times 6 is 18. Plus 2. Pull out your calculator. And you will see that that is 11 meters per second squared at the endpoint of t equals 3 seconds. Now, here's the most interesting question, really, well, to me, because it applies to what we're going to be doing a lot of. When, if ever, does the body change direction? Okay, so let's get a new page and answer that question for this problem here. If it changes direction, this is what I'm trying to get you to understand. Velocity must change from positive to negative or negative to positive. So we find the velocity function, which we've already done. That was 4t, nope, that was t cubed minus 3t squared plus 2t. We're going to set it equal to 0 and solve for t, because we want to find when is the velocity equal to 0. So let's see what happens if I factor out a t. Hopefully this is something that factors easily. Looks like t minus 1 and t minus 2. So at t equals 0, t equals 1, and t equals 2, these are possible times when it changes direction. We have to verify, and we have to also keep something in mind. At time t equals 0, it can't change direction. That's when it starts. So you can eliminate that one. That is not going to be one of your answers. Okay, so what we have to do is set up a number line and check the sign of our velocity function. So let me write that down up here. T minus 1, t minus 2. And we're going to check the sign of the velocity function at these times. Well, we know it starts at 0 and it ends at 3. Here's 1 second. Here's 2 seconds. And so what we're doing is we're setting up test intervals. We're going to check the sign of the velocity function in these intervals. So you need to find something that you can plug in each of these intervals and check the sign of the velocity function. Now the way I do it is I'm only interested in whether it's positive or negative. So I don't find the actual value of the velocity when time equals 1/2. I ask myself, what's the sign of each of these three factors? So when t equals 1/2, t is positive. But 1/2 minus 1 is negative, and 1/2 minus 2 is negative. So if I multiply a positive and a negative and a negative, what do we get? Overall, we are positive. So you can think about it as going to the right or going up in that interval. Now check what happens over here for 3/2. Well, 3/2 is positive. 3/2 minus 1 is positive, but 3/2 minus 2 is negative. So if I multiply two positive factors times a negative factor, my overall value of the function is negative. So in this interval, I'm headed down or to the left, whichever way the problem is set up. So that we do change directions there. We know that right now. At t equals 1. Now check this last one. When you plug 5/2 into each of these three factors, figure out the sign. Well, 5/2 is positive. 5/2 minus 1 is positive. 5/2 minus 2 is positive. So overall, the velocity is positive here. So we change direction at t equals 1 and t equals 2. Go from positive to negative to positive. So we're going to be doing this kind of thing a lot to analyze graphs. All right, we will do one more if you have the time for it. Let's go through these steps for the second function down here. All right, displacement is going to be s of 3 minus s of 0. So when we plug in 3, that's negative 27 plus 27 minus 9. So the displacement is negative 9 meters. That's the displacement. Find the average velocity. Well, that will be, let's write it a little better. We'll call it velocity average. S of 3 minus S of 0 over 3 minus 0. Negative 9 over 3. So negative 3 meters per second is your average velocity. The speed and acceleration. Okay, for speed and acceleration, we need to get the velocity function. So what does a velocity function look like here? Negative 3t squared plus 6t minus 3. So at t equals 0, my velocity will be negative 3 meters per second, meaning my speed is the absolute value of that 3 meters per second. And at t equals 3, we get negative 27 plus 18 minus 3, which is negative 12 meters per second. So the speed would be 12, positive 12 meters per second. Okay, so acceleration, maybe do a different color. Acceleration is the derivative of the velocity function, negative 6t plus 6. At time t equals 0, we have 6 meters per second squared. And at 3 seconds, it's negative 18 plus 6, which is negative 12 meters per second squared. So we've done A and B. Now we need to do C. So this is our question. When, if ever, does it change direction? So we need to find when is the velocity function equal to 0, And so what am I looking at here? I think I would like to factor out a -3 before I try to factor this thing. And try to be careful. What do you think? Does that look right? We have to be careful of our signs. We factored out a -3, so if you multiply it back, that's -3t squared plus 6t minus 3. Okay, so how does this factor? Well, how about this? So velocity equals 0 at time t equal 1 second. But we can't assume that it changes direction there. Even though this is a parabola, we're not talking about the shape of the curve. We're looking for zeros of the velocity function. And look what happens here. Does it change? Do we change direction at this point? So let's make a number line. I like to remind myself that we have endpoints. We just have a test interval here at 1. I need to check the sign of the velocity on either side of 1. Now, some of you may have already realized that no matter what we put in for t, we're going to square it. It's going to be positive, and then we multiply by a negative. So the velocity is always negative except for 0. So let's see what happens when we do our test intervals. I'm going to try 1/2 and 2. I have this -3, so I don't want to forget about that. Now, plug in 1/2, it's going to be positive. So overall, velocity is negative in here. Okay, plug in 2, it's going to be positive. So overall, velocity is negative on the other side of 1. So what does this mean? It never changes direction. Now, why does it, how can I make this make sense to you? Let's look at something. So, when the velocity equals 0 does not necessarily mean that the body changes direction. This function right here that gives us the position, um, I don't know exactly what it looks like, but overall it's kind of doing something like y equals -x cubed. And we could graph it, but I couldn't get logged on to Desmos. So, but if you remember what that function looks like, it does have a horizontal tangent. We're talking about this graph. So y prime equals 0 at x equals 0, but it doesn't change direction there. It's always going down. So this is what's happening with this graph of the position. It's always traveling in the same direction. The velocity is just 0 for an instant, but it doesn't change direction there. So it's like it came to a stoplight and stopped for 1 second. So remember, you always have to check to see if the sign of the velocity changes on either side of these places where it does equal 0. Now, on your handout, you'll see you have the complete solutions here. So you can practice this. And now you're ready to do the homework. on Canvas, and also in the book there's some problems to look at if you want additional practice. And let me know if you have questions.